Okay guys, so today we're going to be starting 8.2. So 8.2 is kind of like binomial, but there's slightly different rules. There's only really one difference, and let's go ahead and get into that. So here are the four basically conditions that have to be met if you want to say that something is a geometric setting. The first three are three that are pretty much the same as binomial setting. The first one is each observation falls into one of just two categories, so, success and failure. Number two, basically you have the probability and it's the same for each observation. And three, all observations are independent. So those three are the same as three of the conditions of binomial. Here's the difference. Binomial setting has an n number of finite trials, which means, it ends. This one, n is a little different. N can technically go on forever, but basically the fourth thing here is the variable of interest is a number of trials required to obtain the first success. So that first success being whatever, when that happens, that's going to be your value of n. And that probably doesn't make a lot of sense at this moment, but let me give you a few examples. So, flipping a coin to get heads. So technically, n would be however many tries it takes you to get that, heads. You can flip it once and you can possibly get it in the first try, but potentially you can go on forever and never get a heads. It's highly unlikely you're going to go forever without getting it, but because it's obviously 50-50, but it's a possibility that you can keep getting tails over and over again. So again, n would be finally getting heads for the first time. Alright, the second example I have here is trying to make a shot in basketball until you make a 3-point shot. So you can keep trying to make different shots, or just keep trying, keep shooting the same, from the 3-point line or whatever, and your n is however many times it takes you to finally make that shot. So I know we have some basketball players in the room, so I wonder what your how many times your attempts would have to be to finally get that 3-point shot. Okay, so let's jump into trying to identify if something meets the geometric setting. So here's example 15 from the book. It says, an experiment consists of rolling a single die. The event of interest is rolling a 3. This event is called a success. So basically what you want to do is you want to keep rolling a die until you get 3. Now the random variable is defined as x is equal to the number of trials until 3 finally occurs. So based off of this information alone, you should be able to determine whether or not it is or isn't geometric. So again, you want to check the four conditions. So you want to check if it has success or failure, check if it has a probability, observations have to be independent, and you have to have, be given something of interest, variable of interest. Now this one, I'm hoping you guys have thought about it a little bit, tried it out, maybe determined the correct answer, but here is the correct answer. The answer is that this is geometric. So 1, success is getting a 3 and failure is not rolling a 3. 2, the probability of rolling a 3 is, it's not given, but we can calculate it. It's 1 in 6. Rolling dice is always independent. And then number 4, we are given an event interest, which is rolling a 3. So, yeah, this one is definitely geometric. Here's another example. So example 16 in the book. It says, suppose you repeatedly draw cards without replacement from a deck of 52 cards until you draw an ace. Okay, so again, you want to talk about those four settings. The first one, basically, success is you draw an ace. Failure would be not drawing an ace. The second one is you can calculate the probability, and here's where you get into, into why it's not going to be geometric. The probability changes. It's not consistent. It says without replacement right here. That right there is like the big key, the big emphasis. When you see that without replacement, you can already determine the probability is going to keep changing. Every time you take a card, you're going to have a higher chance now of getting an ace, and they're not independent because you're taking the card out. So that's the answer. The without replacement basically destroys the independence, not geometric. Okay, so calculating probabilities is something that's going to be important. I guess this first section kind of parallels what we did in binomial, We talked about what the binomial setting was. Then we talked about how to calculate the probability. Well, here you go. So here's the formula. I'm not going to read all this to you guys. I trust that you can read this. But here's the formula. Essentially, we're going to need two things, the probability and then n, the number of trials. N should usually be given to you. They're going to ask you, what's the probability that it took this many trials? It took like 5 trials to finally get that success, or it took 10 trials. So this is the formula we're going to use, and I want to go ahead and jump into an example. I want to talk about example 15 again. So I want to use that same scenario. So again, the experiment is rolling a single die. The minimum interest is 3. So that's what you want to get. Now, find the probability that x is equal to 4. So that what this says is find the probability that it took you 4 times to finally get that 3. So you kept rolling the die until that happened. So let's get into the formula. So here's the formula, and here's what I want. And yes, I already have it all worked out for you guys right here. And I have it typed up this time because my handwriting, it leaves much to be desired. So here's the formula. Now, right here it says that n number of trials. So the 4 is the n. And then again, probability wasn't given to us, but trying to get 1 out of the 6 numbers on the die is 1 out of 6. So that goes here for the probability. So I plug that in for both of these places, and then I plug in the 4 right here. Now, after you write this down, if you have this, you can just plug it into a calculator and it makes your job a lot easier, but be very careful with how you put the parentheses. I always have trouble with how many parentheses I'm supposed to put, so I prefer doing this part first, and I got this number, and then multiplying that by 1/6 to finally get my answer here. And we should make these approximately, because technically it's not an exact answer, So that's pretty much it for this section. Not this section, the first part of this section. We still have a few more days. We're going to kind of parallel what we did last week with the binomial settings, and we should end up having probably, I want to say, another quiz soon or a test. I'm thinking we might finish all this up by possibly Thursday, and then if that's accurate, I'll be giving you guys a practice test tomorrow or the day after. If you have any questions, hopefully I'm around. The meeting that I'm supposed to go to is not supposed to be very long, but yeah, I'm gonna go ahead and stop talking now.